So the topic today is serialization in Spark notebooks in Synapse. Now, although this is about Synapse, you can pretty much use these techniques in anywhere you use Spark notebooks. You don't really need to have any experience with Spark. If you do have experience, from this session, you will learn and understand how to use these techniques to optimize your Spark notebooks. If you do not have experience with Spark, I think you will still get something meaningful out of it, as we will understand how exactly the serialization in Spark works, which is a very important concept. My name is Sandeep Pawar. I won't spend much time in introduction. You can just follow me on Twitter at PawarBI, or just follow my blog at pawarbi.com. So why exactly we care about the serialization, and what does serialization mean? So all this started because I was looking at Microsoft documentation on how to optimize Apache Spark jobs in Azure Synapse Analytics. And if you click on this link, it will take you to the documentation page. If I scroll down a little bit here, you will see that it says right over here, optimize the Spark, optimize data serialization. And what it says here is Spark jobs are distributed, so appropriate data serialization is important for best performance. And there are two kinds of serializations, the Java serialization and the Cryo serialization. And it also recommends that you switch over to Cryo serialization for optimization purposes. So let's take a look at exactly what that means and how you can switch from Java to Cryo. If you're new to Spark, just a quick introduction here, that what serialization exactly means. So when you create an Apache Spark pool and then create submit a job to run a transformation or do some sort of an analysis of something, what happens is you create two things. A driver, you have a driver which is responsible for assigning the tasks, submitting the logic behind your transformation and everything. And there are executors, the nodes. Those are the workers that actually carry out the job. So imagine these over here, these executors are like little computers, and the driver is a main computer where you're working, and a resource manager is there to assign resources like memory and the CPU to each of these executors. So the job starts from here. It goes to each of these executors. So let's say I have a data set that has product key, customer key, order quantity, and the unit price. It is partitioned, and it goes to each of these executors. Now, inside these executors, for the Spark driver to send it over to the network, if you're working with a large data set, let's say tens of gigabytes of data set, it has to be compact, because otherwise it's going to cause a lot of memory and network overhead. So what Spark does, it serializes it. So essentially what that means is it converts it into bytecode. So 010101. I'm just simplifying things, but it is much more efficient to send it to these executors by serializing it into these bytecodes. Once it reaches these executors, then it will deserialize it and then do its process. Okay, so that's exactly what this serialization means. And there are two types of serialization. The Java, which is the default. The Spark is all written in Java, so that's why it creates these Java objects. And then Cryo is a third-party serializer. And it's been shown that Cryo serialization, it's almost 10 times faster than Java serialization, and that's why you should use the Cryo serialization. So let's take a look how we can do that in the Spark notebooks. So what you have to do is, by default, it will be Java serializer. So, but I'm setting it explicitly here that, hey, Spark, set the configuration for the serializer to be Java serializer. I have a data frame, very simple transformation. I'm just pulling a product key, customer key, and counting a distinct on it. It takes 2 seconds for 30 million rows of data. So pretty fast, right? So Java serializer took 2 seconds. Hopefully the Cryo will be even faster. Let's take a look at Cryo. The process is exactly the same. What I'm going to do is Spark on set the serialization to Cryo serialization now. And you can see here the serialization has been set to Cryo, but it still takes 2 seconds. So what exactly happened here? Or didn't we expect the Cryo to run faster? Well, yes, Cryo is faster, but it matters where you're running it. So it turns out that when you're using Spark, PiSpark, or Spark SQL, the Cryo versus Java doesn't really matter because Spark actually uses the encoders, which if you see here is much faster. The longer the bar, the better, because you're able to send more objects, the Java objects, across the network, so it's much better for us. So you can see the encoders are significantly faster than Cryo or Java. So the tip that we got from documentation that hey, convert to Cryo, it doesn't really so much matter. But does serialization matter after all? No, it should. And it turns out it does, but it matters how you are accessing it. So what I'm going to do in this case is I'm going to convert the data frame that I just created, the Spark data frame, into a data set. And the difference between a data frame and a data set is that a data set can be accessed via Spark SQL, and it is a strong type. PiSpark, on the other hand, it only has access to, you can only access and create data frames. With data set, you can use the data set as at the RDD level, or you can also access it using the data frame API. So what I'm doing here is to convert it into a data set. What I'm going to do is take the product key, customer key, and then create a class, and then specify the types, and converting that into a data set that, hey, take this data frame and then convert it into a data set with sales as the class. And then I'm going to apply some transformations on top of that. So very simple transformation, but I'm going to do it 2 different ways. The first way is using the lambdas. So I'm taking the data set and then filter, and then I'm going, if you're familiar with programming language, I'm using the lambdas here to access the data row by row. So I'm taking, hey, take this series, take this data frame, access the data key, and for every element that is 310, just keep that. So pretty simple stuff, right? And if I do that, if I apply these transformations, it takes 21 seconds for 30 million row data set to run, to do all of this. If I use the data frame API, remember I'm still using the data set. It's what's the difference between what I showed previously and this is what API I'm using. Earlier, I used the lambdas, whereas in this case, I'm using the standard data frame API. And if I do that, it runs in 2 seconds. So what changed? The data set is the same, the type of artifact that we created is the same, but how we accessed it is different. The reason being, when you are using the lambdas like this that I showed here, the lambdas, you're actually accessing the data set at an RDD level, which has to serialize and deserialize, which adds to the overall bottleneck. And that's why it ran so much slower compared to this. So the bottom line here is always stick with the data frame API, and you should be all good. It also matters when you're using PiSpark, because in PiSpark it's even worse, because you're creating a Spark job, and then you have Python, so you have to go from Python, then pickle it, use pickle serialization, go to Python, run it in Python, and then convert it back, deserialize it, and convert it back to Spark. So you have a double whammy here, and it can be significantly slower. You can get over that by using Apache Arrow. So when I said PiSpark, by default, it uses Pickle as the serialization method. Um, we can use Apache Arrow. Apache Arrow is a columnar engine, just like Vertipack engine. It is zero copy, and it doesn't require the serialization, deserialization process, or it is minimal, and it can speed up your process significantly, and you don't really have to do much. So as an example, if I take again a data frame and do two pandas, with the defaults, it takes 24 seconds to convert it. Whereas if I enable the pi arrow, so all I'm doing is configuration set to arrow is enabled to true with this one single statement, and when you run it, it takes 12 seconds to run. In real life, you might see, depending on what you're using, how large your data set is or data frame is, you can even see significant speed up. In this case, I'm using a 30 million rows. So when you are converting it to pandas, it's all held into the memory. So it can be slower depending on how much data you have and how you're accessing it. You have to just be a little bit careful, because again, when we are converting it to pandas, even with arrow, we are not parallelizing. It's going to all send it back to your master node. So yeah, so that's about serialization. So two takeaways from here. First, you have to optimize it so that you can use your encoders as much as you can. And then second, if you want to convert it to pandas, set the arrow to enable, and you should be good.